So Docker containers are basically, before getting started with the containers part, we need to understand what does a container mean. A container is basically a standard unit of software that packages up code and all of its dependencies, so the application runs quickly and reliably. For example, you were given a task to develop a RESTful API, for example, using um, an MVC framework. It could be in Python, Django, and it could be in PHP, Laravel. So when the APIs are ready, now you need to ship your solution to an environment that could open those APIs to the world of internet. So now, in order to ship those dependencies, rather than setting up all of the environment by yourself, by logging into your maybe AWS services, setting up an EC2 and running and like installing all those services in there, what you do, you basically install all your packages. For example, for running the RESTful APIs, you are going to need an MVC framework, that is Laravel. So Laravel runs on PHP. So you will be installing PHP on your container. The second thing that you will need is the Nginx server, or maybe Apache, the web server, and so on and so forth. So these are the utilities that you are going to install on the container. But this will be done only once while you are developing your stack, and then you like move your stack from one place, from one environment to another. That makes it easy to ship container based application from one environment to another, and that this is what that the slide says, that it gives us more reliability in terms of moving our software solutions from one environment to another. Before building a container, we basically need to understand few concepts that are related to containers, especially Docker. And now I move on to my next concept, that is about the images. So image is basically an an executable package that includes everything. So when we need to develop our container, we first need to write the configuration, and those configuration basically are part of the file that is called a Docker file for Docker containers. Once the file is compiled, so you get an executable package, and that executable package is redistributable. And how that redistribution is done is something that we will be covering throughout the session. So now we have our Docker file in place. The Docker file is built, that is compiled using Docker to develop Docker image, and a running instance of an image is called a Docker container. This concept can be related to a class and an object. So an image is basically a template, a class, and container is basically a running instance of that template of that class. There has been, a little difference between how Linux containers work and how Windows containers work. And Linux containers usually works on macOS as well, but these two scenarios are something that needs to be discussed separately. So first thing first, that they don't work the same way. The second thing is containers built on Windows or Linux cannot interchangeably run on both platforms. That is, Windows containers cannot run seamlessly on Linux, and the containers that we have built on the Linux environment cannot be shipped to Windows without doing some modification on the machine level. So for running Docker for Windows, basically Windows platform runs containers inside a virtualized environment that is basically favored by or supported by Hyper-V, that is Microsoft's virtualization technology that makes it possible to run Linux-based kernels onto Windows operating system. And similarly, if we are working on, for example, a .NET-based application, so a .NET-based application will be eventually deployed in a Windows environment, and that Windows environment, in case of containers, could only go into Windows containers. So if the Windows containers need to run in terms of interchangeable and cross-platform compatibility. So we need to again run a VM on Windows. So from here, the takeaway is containers are more friendly and have more support in terms of open source and in terms of Linux. But when it comes down to Windows and other platforms, so their support is rather limited. But there are solutions available, and we can make containers run on all of the available operating system, major operating systems, that is Linux, Windows, and Mac OS. So what is Docker? Docker is basically an open source platform that helps us developing our applications fast, shipping our applications, and running applications. The second point that goes in favor of Docker is Docker basically allows us to package an application with all of its dependencies into a standardized unit for software development. For example, I was giving example of this RESTful APIs that need to run on a Linux environment. So rather than doing all of the configuration setup manually, by setting, for example, by setting up a VM, what you will do with Docker containers, you basically create a configuration file, and that configuration file becomes basically the application stack of your whole environment. And now you don't need to redo all those stuff, all those configuration again and again and again. Even if like multiple developers are working on a digital product, on a solution that they are supposed to develop together. So even in that case, if one developer, that could be the lead developer of the group, sets up all of the configuration and environment using Docker containers, usually it is done through Docker compose.yaml file that I'll be showing you guys in a while. So that basically helps us package everything into a Docker, into a configuration file, and then just distribute that file to all of the developers, even for dev environments, for staging environment, and for production environment. That's basically the standard stages that a software has to go through while the software is being developed. These are some of the major components that we need to understand. We need to make ourselves aware of when you install Docker on your operating system. So that gives you the very first component, that is Docker daemon. Daemon is called in Linux environment, and the same process is called service in Windows-based platform. So this Dockered or Dockerd is the service that keeps on running when you have Docker environment set up on your machine. It could be a server or your personal laptop. The second thing is client that we need to interact with this Dockerd. And Docker client and Docker daemon is basically part of this Docker engine that are running on our machine or maybe on a server. This Docker client or Docker engine can communicate with registry, and there are like different objects that are associated with this whole Docker-based ecosystem. In extension to Docker client and Docker server, Docker engine is basically it is a group, and it's basically a client server application. The server is daemon, as I explained, and the server is called Dockerd. And client is basically communicating with the server with the help of these REST APIs that are packaged within the Dockerd environment that we get when we install Docker on our machine or on our server. This is how a Docker engine looks like in a nutshell. And today we are going to work with Docker CLI. I will give you guys a demo about how we communicate with Dockerd, the Docker server at the backend, and how these commands are like written in the Docker CLI. We will be looking at the logs and the image management, this component, and the fourth one will be Docker Compose. When we start working with Docker and we need to develop our container, we first need to develop the images, and most of the custom images are usually based on some parent images that are part of the Docker registry. Uh, and in case of Docker, that Docker registry is called Docker Hub. One thing to notice here that there are like other registries available, like Google registry for getting these images, and some large enterprises can also set up their own custom registries to work with their custom images, because they just don't want to share their data with outside their of their enterprise due to the GDPR or other regulations in place. So this Docker Hub will be our place to go whenever we need any kind of images. For example, if you are working with Python, Django, and you need to set up a web server, so you simply go to Docker Hub and fetch the Nginx server from there. You don't need to develop that by yourself, but there will be changes. There will be configurations that you need to perform on top of that basic image. So that is the point where Docker images comes in. And most of the images that we take from Docker Hub, they are going to be read-only templates. We cannot modify them, but we can build on top of that. And how do we do that? It's basically done using Dockerfile. And a Dockerfile helps us modify or build on top of what's available. You will get more understanding of how the Docker images are being built and how do we modify or build on top of the available images during the demo. This is how, this is a screenshot of our today's demo. This is a Docker file that is going to be built on top of an image that contains PHP 7.2, FPM for running PHP and for compiling PHP, for example. And on top of that, we are running these apt get update and apt get install commands. So now you can see that our parent image that is part of our Docker file is basically PHP 7.2 FPM, but that image also taking something from Ubuntu. That is why we are able to run apt get commands inside the container as part of our Docker file. Once we have all our configuration in place, so those configurations can be built into an image. Once the image is ready, now you don't need to perform all of the steps again and again. You don't need to install these libraries that you need to run your software. You don't need to install these extensions that you need for to be working with Docker containers inside the container. So once the image is ready, it's a reusable template that can be used by other developers. Same image can be used to deploy your solution to different environments. These are some of the layers of Docker images, because a Docker image it's basically a set of layers. And here we need to like compare the Docker images with the with how version control basically works. When you do any change in your code, so it's not always the whole code base that you are going to commit and push. It's always the change that is going to be committed and pushed into your GitHub repo. So the same way, the same concept they have applied to these Docker images. So whenever you take a base image, for example, we are using PHP FPM in the previous in this slide, you can see that we are taking PHP 7.2 as our base image. And on top of that, we are like adding more utilities that will work with PHP. So this is the same thing that is shown on in this image, that we have this read and write layer as on the top, and rest of the layers are in read-only form. You can see that they are logged. They cannot be changed. This is what I was referring to when I said that this PHP 7.2 is kind of read-only more, and like we are building on top of that. This is something that that is asked as a concern when we work with Docker containers, because Docker containers are introduced and they have like positioned themselves in a way that they favor the experimentation. They help developers and technical people to like build stuff, to destroy it, and like experiment with new things. So in this pursuit, they have been like asked, then how are you going to persist your data across different containers? So there comes the Docker volume. Docker volume is basically the way, the concept that Docker uses to store data. So the volume basically exists outside of the container. A Docker container is always communicating with these Docker volumes. So you can take it as a small hard drive that is always that always sits on your laptop, whether you are running service A or service B. So these Docker volumes basically help us persist our data. When we like build new containers, we remove or stop any containers. So whether we stop a container or remove a container, the volume is going to persist. The data is going to stay there. Whenever a new container comes in and try to connect with the existing volume, that container, the new container will have access to the same data that was generated by previous containers. This concept, I will get into this concept, the bind mounts, when I talk when we like move on to our demo session. So when we have like 3-4 containers running on a machine, those containers need to communicate with one another. And for the communication, to make the communication possible across containers, we need to have some sort of network. By default, Docker Docker sets up a bridge network between different containers, and those containers can communicate with one another over the bridge network. But if a container is outside of the bridge network, that container might be a part of your might be running on the same host, but the container cannot access or cannot communicate with the with other containers, because they are not part of the same bridge. So containers on the same bridge can communicate, and containers that are not part of the bridge network, they cannot communicate unless they become part of the network. And how do we do that? This is something that we'll be talking about in our demo today. This is a high level overview that a web container is running and a DB container is running. By a web, I mean, for example, Python Django or Laravel PHP. And by DB, it could be MySQL and Postgres, and they are communicating with one another via a bridge network. This is how a Docker environment look like in a nutshell, that the client is basically building and is basically building the images. Sometimes it pulls the images from Docker Hub and then run it. When the image starts running, it becomes a container. It could be one container or multiple containers of the same image when it comes to scalability of the solution. And the images will be coming from the registry. It could be Docker Hub or any other registry that you would like to use. So now we continue with our demo part. The demo is going to be a web application that is developed with Laravel. The application runs on Nginx and it connects with MySQL. Before we get started with the demo, I think it's a good time to get ourselves familiar with Docker. For hosting operating system, the Docker is basically running on a host, and that host could be Linux, Windows, or Mac. The Docker CLI is going to give commands to the Docker daemon. Docker Compose is basically a tool that helps us code our whole infrastructure, our whole application stack in a file. PHP is a scripting language for web. Laravel is basically a PHP framework for web development. Nginx is, most of you guys may already be familiar with, is a web server. MySQL is a database server, and Composer is our package manager. If you are like not familiar with Composer, it's pip for Python. So now let's start with the demo. Let me share my screen again, and we are, yep, good on time. And in order to show you, I think I need to share now my whole screen with you guys. So my screen is visible to you. Okay. The first thing first, this is our Docker file, and we are starting from this PHP FPM image. The first part before the colon is our image name, and this 7.2-FPM is the tag of the image, because when you go to Docker Hub, you will find multiple images for PHP, and with the help of tag, we basically specify which PHP image we need for our solution. It's the same thing that we do with our GitHub repos. When we create builds, we tag them, and that tag basically define the version of the solution. Then we are installing some libraries. Git is like very familiar for to work with version control. That is going to be part of our container. We are going to need curl for HTTP request and response thing. For example, this zip and unzip library for our use cases. That's only for there, just to give you guys a perspective that how we could install different libraries for for the language that we are working with. That is PHP in our case. Some of the cleaning to keep the image size reduced, because that is very important when you are like working with multiple images and building multiple containers. This statement, that is docker php ext install, is basically a way to install PHP related extensions within our container. So for Python, it is going to be pip related commands and Python packages. This statement, we are basically copying the composer file that is going to be our package manager for this demo, and this will be installing multiple PHP packages for running Laravel. Although these concepts may sound like they are very language dependent, for example, I am like talking too much about PHP, but that is not the case. Basically, every language has some sort of utilities or libraries that ships with it. So the only thing that is going to change is the name of the library or the language. All of the concepts will remain the same. So there is going to be a working directory for any web server. So whether you are using PHP or Python, so this working directory command basically changes the directory or makes the HTML directory as the active directory when we log into our container. And then we set some ownership permissions for the folder. This is something very typical to Linux environment. And how are we going to use this Docker file with the help of docker compose.yaml file? Because in practice, when you are like working on some real software projects, or you are working on an open source project, so you are going to like use this docker compose file, and this docker compose file has multiple services listed within it. First, it basically specifies the environment file. So this is our environment file, and environment file lists all of the versions that we are going to use. If it says DB version 5.7, that means we will be using MySQL 5.7 for our demo. And some of other constants, environment variables that we will be using to access the database or create the database on the database server. And here we basically, under the build argument, we specify our Docker file, and that Docker file is right next to the Docker Compose file. The both files are part of the same directory. In the presentation, I was talking about volumes or bind mounts. So this folder, this Lara app folder, is part of the host. By host, I am running Ubuntu. So for this demo, our host is Ubuntu. And this Lara app folder, I can show you that it is here on my on my machine. But this folder is not accessible inside the container. This folder, Lara app, is not accessible inside the container unless I bind mount them. I mount my folder within the container into HTML so that it becomes accessible inside the container. And now Nginx can access this folder as a web root and can serve the HTTP requests that are being sent to the web server. Some environment variables, again, and this depends on command is important to understand, because depends on is basically defining a sequence as well. Before this application server, this application container gets started, the MySQL server, the MySQL container should be running, and this container will be linking with the MySQL container. So at this place, we are basically defining our application access and how the application is going to connect with the database server. And these two and our application server, that is going to be called Lara app or simple app, is going to be part of this Lara network. And this Lara network is basically uh, a bridge network that we are defining right down here in the compose file. So this Lara network is going to be a bridge network. So this is something that we also need to define in our compose file. Another service that we need for our demo is the Nginx service, and we are using we are like naming the service as Nginx. We are using Nginx image from Docker Hub, and we are specifying this version for the image as well. And it is a good practice to name all these environment variables into a .env file so that it makes it easy for you to upgrade the system whenever there is a need for an upgrade. There we are basically specifying, we are basically mapping the container port that is going to be port 80, that is the default port of Nginx, where Nginx server will be running, and we need to map this on our host machine, that is Ubuntu. And this Nginx port is going to be listed in our env file, and it says the Nginx port will be 8080, and eventually our application will be running on this port on the host machine. But even that mapping has to be part of the Docker Compose file. One last thing that is important to discuss is this volume thing, that we are defining this explicit volume in this case, and this volume is called dB. And when we define our MySQL service, so this MySQL service in here, this MySQL service volumes is basically mapped with the MySQL, with the var lib MySQL folder that is inside the container. So this var lib MySQL is the place where MySQL database server installs or stores all of the data related files, all of the database related files into this place, and that place has to be preserved from one container to another. Even if this container has been stopped or removed, the volume is going to consist. And when a new MySQL container has been launched, that MySQL container will be able to access the same volume. And the port mapping remains the same. Once we have all of these commands listed and there are like no errors, no issues with the file, we simply go and run this command docker compose up for taking the configuration from our YAML file, starting the services one by one, and the sequence of the services will also be taken care of by this Docker Compose tool, and they will be launched in a detached mode so that the terminal becomes available once the services are running. So, yep. You see, first the MySQL database server is being launched, then the application server gets started because the application container has a dependency on MySQL. And same is the case with Nginx. Nginx comes after application server or database server. So that gets started after the application container has been running. We can do Docker container ls to check what containers have been launched. And this shows that we are running something on this port 8080 on our local host. That's the IP address 0.0.0.0. And the container port is 80. So this 80 is coming from the Nginx container, and that port is mapped on 8080. Similarly, this 3006 port 3306 is mapped to the 3306 on my host machine. So if the same port names are available, they can be used. But if this 3306 is being used by another service on my host machine, then you will get an error that the port is not available. So you either stop the service that is running on that port, or you change your port into your .env file and start your containers again. And now when we go uh, here on, like, there you go. So now we can see, like, the application, Laravel application is running, and there are like some of the routes available for login and register. And how this is working: first we send the request to our Nginx, and that Nginx server has access to our application code. And how does the Nginx server know where the application is? This is where the bind mounts come in. We are basically mapping our Lara application inside the container with the help of mount points. And where are those mount points? Those mount points are basically part of our compose file, in here. There, this Lara app, it has been like mounted inside the container at this point HTML, and this is our web route for uh, the Nginx web server. There is one extra service that I have like made part of the application stack. That's basically a client for accessing the database. Just to give you guys a little more perspective on how the clients can interact with the database server. So that solution, that PHP MyAdmin, is basically running on 8081 because like both solutions cannot run on the same port. So our application is running on 8080, and the PHP MyAdmin, which is another application, that application is running on 8081. And to validate whether our configurations have been successfully applied or not, so this database password that is coming from this .env file, we can use this root password with username root and tries to log in, and it works. That shows that we are successfully connecting our front end service, that is the PHP MyAdmin service, and that's a container. It's running inside a container, a separate container, and that container is listed over here. This container is able to connect to another container that is called MySQL. And now they are like communicating with one another. And how do they communicate? And because they are like part of the same bridge network. That's the reason they can communicate with one another. And here we have these three tables defined. If we like create uh, uh, any new new table here, so just in case, uh, with only one column. So now this table is newly introduced table, and that resides in the Docker volume. And this volume is going to persist even if we remove our all of, for example, first I will be stopping all of these containers. And now if I remove this MySQL container, a running container cannot be stopped. If you try to remove that container that has been that is in the running state, so you will get an error by Docker, and that's basically part of the Docker engine. And um, now I have like removed the Docker container for MySQL, and now we are going to check if the volume persists, if the table that we created on the volume does that does that exist or not. So no containers running, and now I am going to start my services again with the help of Docker compose up -t, and we have started a new Docker container for MySQL. The container is running, and the table is there. Even the new, new container, new MySQL container is able to connect with the Docker volume that has been initially created by the Docker compose file, and a MySQL container was able to connect with it. Then we removed that container and we created a new container from the same image, and that container is able to connect with the same Docker volume. So that shows Docker volume exists outside of the solution, outside of the container. And if a container is stopped or being removed, the volume still stays there, and there should be no concern about the data persistence about these Docker containers. That is it that I have prepared for the demo. Now let's get back to the slides. And there are like two halves of the presentation. First, I'm supposed to talk about the Docker containers, how do they work with the demo, and what lies beyond Docker containers. What are the new technologies that will be coming in the space of virtualization or cloud native applications? So microkernels and a little bit more specific term, unikernels are like more advanced concepts that are being researched about. Some of I mean, I should say like in the past 4 or 5 years, much progress has been made for the microkernels. They are not production ready yet, as per my knowledge, but there has been very active research going on in this domain. Even the companies like Google and Microsoft, they are like very much interested into having these microkernels, and microkernels are basically more light and more specific kernels that could run a service. So for it's basically light operating system. You don't need to be running all of the services that you don't need for a particular setup. For example, if you are going to run a web application, so that web application might need access to to input and output devices on the machine, to the network devices. So only those services has to be part of the kernel. A web application has nothing to do with high graphics, for example. So those high graphics oriented utilities don't have to be part of the same kernel. Now the discussion that is going around these microkernels and unikernels is to make the kernels light, to apply the same approach that we applied to our applications when we moved our old monolithic applications to microservices and divided the whole application into smaller components. The same approach we are doing with Docker containers. We are like, rather than having a whole VM with everything, with MySQL, with PHP, with Redis cache, for example, and all other stuff, we are like coming up with different container approach. If one container goes down, so the others remain healthy and that container can be fixed. So that kind of increased the reliability of the system. For container orchestration, this is something that you might already know about this. K8 Kubernetes is used for container orchestration, whether you are like managing your containers on premise or on cloud. So these are some of the technologies that are being discussed after Docker containers in the virtualization space. Any questions regarding the presentation? Just in case, I mean, if there are no questions about the Docker containers and the technologies we are like talking about, thank you very much for joining us for this EDISS talk. This is our second talk, and we are hoping to get more EDISS talks in the coming week. See you in our next EDISS talk next week with another interesting EDISS talk.